All right, guys. So I want to apologize for not being in class. I'm still on jury duty. So I thought I'd make this video to hopefully clear up some questions you possibly have. If you have more questions and nobody in your group knows how to answer them, please go after school, talk to Miss Barron, Mr. Ormsby, Miss Yamashiro to clarify a few things. And hopefully, fingers crossed, I will be back on Monday. All right, so right now what we're doing is we're looking at your methods and meanings box, and I kind of want to go over what you should have gotten in class on Wednesday. And you're looking at the triangle similarities, okay? And we have three triangle similarity conditions, okay? And as you can tell, it's the AA, SAS, and SSS. So I want to just talk about those and then give some examples so that way we know really what we're looking for and what I expect you guys to be able to do and produce in this next lesson today. All right, so let's talk about AA. So go ahead, pause this video and take out your notebooks. All right, your notebooks are out. So let's talk about similarity. So whenever you see this little squiggly line, that is telling us that something is similar, right? If you see the equal sign with that squiggly line above it, then you know that it means congruent. So our first one for triangle similarity is that your angles, two of them, have to be congruent with each other. Okay, so if two pairs of angles are congruent, that means ultimately the third angle will be congruent. So if angle A has this little line, this dash, I should say, that means angle A and angle D are congruent to each other. So they're equal to each other. Okay, notice that it has two lines on B. Notice that E has two lines. So again, this angle B and this angle E are congruent. Another way that you might see congruency is if you see instead of little tick marks on that semicircle, you might actually see, you know, 1, 2, 3, and then for F, you would see the 3. Okay, so if we label A as a certain number, right, that means that that D would also be the same. If B was a certain number, then E would be the same. So for just fun, right, we know that, so if I make this, 20 degrees, then what would be D? D would also be 20 degrees, right? If I make B, let's say that it is, I don't know, 60 degrees, just making this up off the top of my head. E is also 60 degrees. Again, the triangles would be similar to each other. Obviously, the lengths don't have to be exactly the same to be similar to each other. And if you add these angles up, you know that you would be left with 80. What does a triangle add up to be? 180, right? So that means that this angle would have to be 100 degrees. And if you do the same over here, what does angle F also have to be? 100 degrees, right? So you have all three angles kind of match up together. You don't need that third angle because of knowing that your triangle always adds up to 180 degrees. It's kind of given information. Okay, so that's the first triangle similarity. The second one is SAS, right? A little bit of sass in your life. Okay, so with SAS, it is important to know that you are going to have not only congruent sides, but also a congruent angle. Notice that your sides, right, are in between your angles. That's why it's SAS. It's not SSA, so you're not going to see side, side, and then an angle there. Okay, and really what you want to do with this one is you want to create a ratio, and the ratios are they're going to be the same essentially, right? So if I take the KB and I divide it by the B, right? So if I say KB over B, notice that the B's are going to cancel out. What are you going to be left with? You'll be left with K. If I take the KA and divide it by the A, KA, oops, divide it by A. Again, what do you notice? The A's cancel out. what are you left with? K's. So the ratio, right, this ratio of this triangle are the same. It's a K. So either it's shrinking or it's growing by that letter K. So as long as they're the same, as long as you can produce the same number, you will get your, we can say that two triangles are similar by SAS. And then obviously this angle has to be the same. Okay, but what happens if we weren't given an actual angle, right? We're just given our three sides. So the last one is side, 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 similarity, right? So I have the KB, I got the KC, I got the KA, and then just A, B, and C. So we would set it up just like the same little ratio here. So if I say, KA all over A, this is the same as KB over B, and this is the same thing as KC over C. Notice the A's cancel out. What are you left with? K. The B's cancel out. What are you left with? Also K. And then obviously the C's cancel out. So your whole ratios are equal to each other, right? So again, this comes directly from your methods and meanings box. So if you need to pause this video and take a look at your methods and meanings box in your homework, please do. Okay, but if not, let's go ahead and let's do some examples. So that way we can actually prove it with some numbers for your triangle similarities. Okay, and then you can start on the lesson today. Okay, so two things we're going to do. I'm going to show you three examples, one for each of the triangle similarities, and we're going to use a flow chart, right? Let's get some practice with the flow chart to prove the triangle similarities. Okay. So let's take a look, pause it, copy down these problems. Great, and we're back. All right, so we want to figure out, are these triangles the same? Again, we can't assume just because it looks like it's a right triangle. We can't assume that it is. All right, notice that I'm given three lengths of the sides. So I'm assuming that this one's going to be the side, side, side. All right, I'm not given any angles, so that's a very good assumption. All right, so I want to find the ratio. So I'm going to go ahead and do my my A over C. So A over C, and it looks like A over C is going to match up with H over F. So H over F. So what is A over C? A over C is 84. H over F is 14. All right, well, I do know that 2 goes into both 84 and 14 right away. So 2 goes into 84, I believe 42 times. Think about that. Yes, it does. Okay, great. And 2 goes into 14 7 times. And I can simplify that. 42 divided by 7 gives you 6. So I got my first ratio as 6. So if I multiply 14 by 6, boom, I got 84. Okay, so there's my first ratio. And so let's do the AB this time. So AB, and it's going to match up to HG. So AB is 72, so that's the length. And then HG is 12. Perfect. Again, I'm not exactly sure off the top of my head. I'm assuming it goes in 6 times, but let's not assume. Let's actually figure that out. So 12 divided by 6, that's easy. That's going to be 12 divided by 2, excuse me, is 6. And 2 and 72, I believe, is 36. And look at that. That gives us 6. Perfect. So we're 2 for 2. Notice that they're the same. Now, in order for this to be proved, this triangle is similar to each other, all three sides have to give you 6. If they don't give you 6, then we're wrong. Notice that I've picked everything for my numerator from triangle 1, and I'm picking everything from triangle 2. You want to be consistent with that. So if you accidentally switch these, you would have gotten a 1 over 6 instead. All right, so last but not least, let's do B to C. And then from here, we'll do F to G. So B to C is a 48. And I got 8 right there. And 48 and 8 goes in 6 times. Perfect. So notice they're all the same ratio. So we do know that they are similar. Okay, so how do we write a flow chart, right? So a little practice of flow chart. So think about where you want to go. You're proving that these two triangles are similar by SSS, similarity. So that means all of this information is going to go into your flow chart. So I would take, here's my first little circle. And again, you can draw the circle first or draw it second, doesn't matter. All right, so my first one, I'm just going to take this information, AC divided by HF, and all I'm going to do is I'm going to say that it equals 6, right? So you don't actually have to put that all the information. If you want to, that's fine. And why is the most important part. So you're putting the information here, and then the why. Why does this work, and why are we using it? We're using it by what's known as computation, right? So we're just proving that that side is equal to 6, right? So it's computation. And I'm going to take the next one, AB. I'll draw my circle after. HG, and that's equal to 6. Again, draw my circle. Why are we putting that there? Again, we were solving, so it wasn't given to us. We had to solve for it, so it's another computation. And then last but not least, BC all over FG. Again, it's equal to 6. Draw a little circle. And why is that true? Computation. Okay? So if I have all three of these, so these are all three sides, I'm going to draw an arrow coming from these bubbles, right, to the main thing. So what's the main thing? I'm proving that this triangle, I'm going to say A, B, C is oops, excuse me, can't read it. So I drew all my triangles, and I'm saying the triangle A, B, C is congruent. So A, B, C is congruent to H, G, F. So H, triangle, H, G, F. Why are these similar triangles? By S, 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 similarity. So not only do we have to fill in the bubbles, you have to tell me why you are putting that information down. Okay? So if you do any work, that's a computation. If it was given to you, you can write the word given and things like that. Right? At the end, it's what you're proving. These two triangles are similar. Why are they similar? By SSS. All right, let's try another one. All right, so here is our problem. So we want to prove that these two triangles are similar to each other. Again, pause the video, and when you're done, unpause the video. Okay, so this problem, we don't actually have a lot of work that we have to do. Okay, so notice that I was given an angle, right? So I know that I'm not going to use side, side, side. I might use side, angle, side, but I was not given actually any sides, so I'm probably not going to use them. I'm probably going to use AA. So for sure, I see these two angles. These look to be the same angle, so we can say that they are congruent to each other. But then also notice that this angle right here should also be congruent. Why? Vertical angles. So this one we can go straight into our flow chart to prove triangle similarity. Okay, so the first one I'm going to prove is, draw my circle, is I'm going to prove that these two are the same. So angle T is congruent to angle G. So why did I write that? Why are they congruent to each other? Well, because I gave that to you. I started off with that problem. So I'm going to say given. Perfect. So this is an angle. So in order for AA to work, I need another one. So again, I'm going to use this vertical angle. And I can't say that this is angle H and this is angle H because I don't know which one I'm talking about. So I need to use all three letters. So I'm going to say angle THS is congruent. I'll start with G for that one because, again, the letters have to match up. So GHF, these are congruent. Why are they congruent? They are based on vertical angles. They're vertical angles. All right, so angles, angles. Draw my little arrows. And now I can write my statement that this triangle, THS, is congruent to triangle G. Oh, I forgot this angle up here. Excuse me. GHF. Circle it up. And you get to put the Y, angle, angle, and then similarity. again, notice I don't actually have to know what that angle is, right? And I don't have to use those two angles because I don't know what those angles are. Okay, awesome. Let's do one more. Here we go. So again, we're going to use a flowchart to figure out these two triangles are similar to each other. Okay, so notice that I used a different marking to tell you that angle C and angle H are congruent with each other. Okay, so that's one way. Notice I was given two sides. So here's an example of side, side, side. Okay, so again, look at the numbers and see if you notice something similar. Again, you would rotate and kind of flip to see kind of what matches up with what. The 10 is going to match up with the 30. The 9 would match up with the 27. So I can say CE. Oh, I totally forgot letters on this one. So let's just make up some letters. So T, X, and Y. Sure. Okay. So CE, and let's do TX. Right. Texas. All right. So CE is 9, and then all over 27. Can we simplify this fraction? Yes, we can. And we get 1/3. Right. And then I'll do the other one. So let's do CD all over TY. Thank you. So 10 over 30. Again, oops, pencil broke. Notice that I got the same number, 1/3. So sometimes you're going to get fractions. Sometimes you'll get integers, right? Which is fine. All right, so let's start with proving that these triangles are the same. So the first thing I'm going to say is I'm going to say angle C is congruent to angle T. Why can I say that? Well, I gave you that information in the picture. So I get to write the word given. Okay, next information, just like example number 1, I'm going to say CE all over TX, and I'm just going to say it's equal to 1/3. Okay, this is given. Oh, sorry, not given. Apologize. That is not given. It's a computation. There we go. And then I'll put the last one. So CD all over TY is also equal to 1/3. Again, why do I get to write that? It is a computation. All right. So angle side side, which is not technically true, it's side angle side, is pointing down. Arrow, arrow, arrow to these triangles. So I'm going to call it triangle CDE. And the other triangle we said was a D. So C matches up with D. What matches up with? Perfect. So Y and then X. All right. And then why do I get to put that? Side, angle, side, similarity. Excellent. Now, if you want to put the information of like CE is equal to 9 and TX is equal to 27, if you put that into your flow chart, you can. You just write the word given attached to it. All right. So those are 3 examples of your SAS. So what I want you guys to do is use this information to kind of help you with the next lesson, which is 2.3.2. Are these triangles similar? So some of them are going to be similar. Some of them are not going to be similar. Okay. If you have any questions or concerns regarding your homework, if you email me, I will be able to get back to you on specific ones. And on Monday, we will go over all of your homework problems. All right. And have a great weekend. I'll talk to you guys soon.